In this video, we'll be exploring the Plot1D tool on Predictive Science's new MHDweb 2.0. This tutorial is part 2 of a 12-part series. It's designed to guide users through this website's data visualization tools. If you've not done so already, it is recommended that you review part 1 of the series, which covers in greater detail this website's architecture, general visualization workflow, and the mass run database. With that being said, to get started with 1D plots, navigate to the MHDweb landing page, which is predpsi.com/MHDweb2, and click on the Plot1D button here. And for this demonstration, I'm going to be selecting the polytropic model for Carrington rotation 2290. So as its name suggests, this tool extracts a one-dimensional slice from a three-dimensional data set by linearly interpolating along an axis or scale while holding the other two axes at fixed values. The 3D data set in question is some variable quantity that is derived from the running of the mass model. You can select the desired variable in the simulation widget here, namely from the variable drop-down menu. The default value for first-time users is the radial component of the magnetic field. However, you can also select, for example, velocity, current density, thermal pressure, or alpha speed. Note that some of the variables' availability is contingent on the selected domain. So, for example, wave energy density, both parallel and antiparallel to the field, is available for coronal domains, but not for heliospheric domains. So I'm going to go ahead and select BR. The first widget that we will explore is the data widget on the left here. This widget is responsible for dictating which one-dimensional slice you'll be extracting from the dataset. For example, when you have a radial slice selected, the latitudinal scale and longitudinal scale are held at fixed values while the radial scale is interpolated along. Similarly, if you were to select a latitudinal slice, the radial and longitudinal scales are held at fixed values. When no value is supplied in these fields, the scale's midpoint is taken. So for this example, the radial scale, we take the midpoint between 1 and 30 solar radii, and for longitude, scale limits are 0 to 360 degrees. The midpoint is 180 degrees. So I'm going to return to the radial slice. One thing that's worth noting, and it's a feature that's covered in other videos within this tutorial series, is that if no value is provided for a field, or if a provided value results in some manner of validation error within the plot generation routine, a modified value will be provided. If you hover over the field in question, a tooltip will pop up with a more descriptive message detailing why that value is modified. So in this example, you can see the red text beneath the field is the modified value. And if I was to hover over this field, it would tell me why that value has been supplied. So in this case, it's because no value is supplied, and it will provide the scale minimum or scale midpoint. If I was to put in a value that is incompatible for this field type, so for latitude, let's say I put in 100 degrees, which is outside of the latitudinal range, it'll provide you a sort of more verbose description of why the value has been modified to 90 degrees. The data widget also defines how the selected slice is transformed. So a slice can be logarithmically transformed, taking the absolute value of, or radially scaled by some power n. So if I was to select that option, you could then specify what r to the n is being applied to this slice. As with many of the other tools that are available through MHDweb 2.0, the data widget will also have a style customization dropdown where you can define certain aesthetic components of your plot. In this case, it would be line color, symbols. For example, if I was to put that on, you'd see the individual positions that are being interpolated at. You can change line width and line style. By default, the units that are displayed along the y-axis are real or physical units, but you can toggle on code units, which refer to the native units that are supplied through the mass model. And lastly, if you would like to remove this text here, which indicates what exact slice you're taking for the Plot1D tool, you can toggle this on or off. The next widget that we'll explore is the point widget. This widget allows users to query a point at a specific position. So by pressing the Query Position button, this feature will be activated. As with the data widget, when no value is provided in this field, it will use the scale midpoint. The queried position is the union of the fixed axes that are supplied in the data widget, along with the value for the variable axis. So in this case, I'm querying a position which is at 5 solar radii with latitude 0 degrees and longitude 180 degrees. So the position that is being queried can be deduced from the text that is displayed at the top of the plot. Similar to the data widget, you can also adjust certain aesthetic components that are related to the queried point by clicking on the Style Customization button here. Here you can change line color, symbols, line width, and style. Also, there's a couple of other options here that allow you to toggle on and off the point that is viewed here with this switch. You can also remove these crosshairs that are indicating where you are querying a position with this toggled switch. And lastly, you can remove the text here by selecting this. And the next widget that we're going to explore is the View widget. This widget is provided to allow users the ability to specify what subset of the slice data they wish to view. So this in effect allows one to zoom in on a particular region of the plot. You can also fix a static y-axis view range so as to better examine how the variable quantity changes at different fixed slice values. Now, just to illustrate some of these features, suppose I wanted to zoom in on this particular part of the plot. I can select the x-axis in the View widget, and right now it's showing the full radial domain between 1 and 30 solar radii, but I'm going to truncate this at 10 solar radii. I'm also going to go back up to the data widget and radially transform this, which is effectively lifting this one-dimensional plot off of that x-axis. Now here we have a sort of closer look at what's going on between 1 and 10 solar radii. And as I mentioned, what you can do with the y-axis is specify a sort of static view range. So let's say I set the axis between 1 and 14. And now what I can do is step through different latitudinal or different latitudes within this radial slice and see how that one-dimensional plot changes as I incrementally move through it. Now, just on a side note, one common pitfall when exploring 1D plots, or really this goes for any of the other tools as well, is that changing certain fields, fields that dictate what particular data set or subset of that data is being viewed, will have side effects on related fields. So just to illustrate this point, currently we're looking at a radial slice. So the slice parameters that are displayed below this slice dropdown, the latitude and longitude, as well as the x-axis, have certain meanings with respect to the slice value. Now if I change it from radial slice to latitudinal slice, the fixed axes now change to radius and longitude, and now the x-axis is referring to latitude. So as such, the value of 10 that was originally supplied for latitude now has a different meaning. Now this is at a radial value 10 solar radii, and the 10 that is supplied down here is now no longer referring to the radial dimension, is referring to the latitudinal dimension. Now also our y-axis is set between 1 and 14 Gauss solar radii cubed, but if I was to take a look at temperature, for example, those now have very different meanings, and in fact the plot can entirely disappear because that no longer has the same meaning. Now we're looking at megakelvin solar radii cubed. So if I was to change the variable value and then be presented with a plot that doesn't necessarily meet my expectations, it might be good to clear these fields, which will return you to default values showing you the full scale range, the full x-axis and y-axis. and then incrementally make changes from there. As with all of the tools on MHDweb 2.0, you can download the plot image that you're viewing by clicking this button here. You can also download the data that is used to generate this one-dimensional slice. For Plot1D and Plot2D, the file format for this data is in HDF4 or HDF5. So by clicking this will fetch and download the 3D data set for the temperature variable that is selected here. You can also request this data by going to the data access tool as well. With that being said, that concludes our overview of the Plot1D tool on Predictive Science's MHDweb 2.0. The next video in this series will go on to explore the Plot2D tool. If you have any questions, comments, or concerns, please leave a comment below. And thanks for watching.